Welcome to lecture 8.3. The focus of this will be on natural language processing. So as I hinted at earlier, clinical data is complex for several reasons. First, it's used to capture sophisticated concepts, such as a patient's health condition. It involves the use of increasingly varied data, including structured, semi-structured, and unstructured data sources. And, it's used by varying constituents at differing levels of the healthcare system, which requires aggregation. So most information in organizations today is unstructured. I think we are moving closer to more structured data, but I still think the majority is unstructured. So unstructured data can be any data type, and does not follow any rules. There's no format or sequence, and it may be unpredictable. And some examples include text, video, and sound. So in healthcare, we have a lot of unstructured clinical data. Largely, it's in the form of physician notes. So take a moment to review this clinical note. It's for an inpatient visit for an appendectomy. What potentially useful information is available within this text? I'll give you a second here. So information that may be more readily apparent includes vitals such as pulse, blood pressure, etc. Reading the note, you can also determine that the patient appears to be making good clinical progress following surgery. There is no apparent complications. Much of this information could prove very useful in both care delivery and in secondary uses of data. So how do we make it more useful? Well, this is where natural language processing comes into play. So to explore this further, let's start with a few more concrete definitions. So what is natural language processing? What is natural language? Well, first, it's languages spoken by people such as English, Chinese, Spanish, and so forth. In contrast to these languages, we have artificial languages that are used in programming computers. Such languages as Python, C++, and so forth are used extensively in providing instructions to a computer. Yet there are few people that actually speak the language. Natural language processing applications then are used to automatically analyze natural languages, looking for patterns in the information that allow us to derive meaning. So text data, of course, is everywhere, right? So most information in organizations comes as unstructured text that results from human to human interaction. These interactions are not structured databases, but it is increasingly in digital form. And these include emails, text messaging, HTML web pages, Twitter feeds, word processing documents, and so forth. So why natural language processing? Well, as people, when we see text in our own language, we can usually understand its meaning, right? However, when computers see the text, they see character strings. A character string is a combination of text characters that may or may not have semantic meaning. So for example, this, I'm not going to try to say it, but WOPIHEWR is a string, but so is patient BP is high. Without NLP, the computer gives equal weight to the meaning of both of these strings. So the problem is, how can we use computers to derive human meaning from text? So natural language processing can be used to answer questions. A great example of this was IBM Watson winning the Jeopardy tournament in 2011. Another good example is the use of voice commands on your iPhone or Android device. NLP can also be used to evaluate text to do such things as gauge sentiment. Good examples include reviewing online consumer feedback for the purposes of classifying reviews. NLP is useful in information extraction. Examples include the ability of software applications to pull appointments from an email exchange and place them on your calendar. And then NLP is also useful in machine translation. If you haven't yet, take a minute and look at the Google Translate application available online. So progress in research is being made on a number of fronts to use NLP in problem solving. Some problems are proving easier to solve, such as the use of NLP to determine whether or not an email is valuable or is spam. NLP is also effective today at identifying parts of speech. So think of grammar correction in a word processing package and in identifying parties or named entities. Progress is being made in a number of areas, particularly in extracting information from natural languages. Challenges remain, however. While IBM Watson revealed our capacity to develop a computer that can answer questions, challenges still remain. Other common human skills with natural language, including paraphrasing, summarizing, and dialoguing, remain difficult at this stage. So despite the progress being made, natural language processing is only as effective as our proper use of natural languages to convey the correct meaning. So here's a few examples to illustrate the ongoing challenge. In the first example here, it's hard to know which word is the verb. Is a teacher striking idle kids, or are teachers strikes idling kids? In the second example, are students cooking for and then serving their grandparents, or are the students cooking and serving their grandparents? So if we're confused regarding the meaning, then rest assured that the computer will be just as confused. So what skills then are needed for natural language processing? Well, first, we need an understanding of language. Second, we need to understand how language is used in a particular domain so that we can understand the correct use of language within the domain and defer the correct meaning from the language. This is of particular importance in the medical profession, of course, which has a fairly unique vocabulary. And finally, we need methods for bringing knowledge resources such as text data together to analyze. So in summary, most information generated today is unstructured text and increasingly digital. NLP provides us with tools that can assist a computer in deriving meaning from unstructured text. It says test, but it should say text. NLP is being used today in a number of common applications, and while progress is being made on several fronts, more research is definitely needed to tackle the ambiguity in human language. All right, there you go.